Welcome friend. In the previous lecture we discussed about the local maximum and the local minimum, and in this lecture we discussed the first derivative test, that is fx is equal to 0, fy is equal to 0, and then we discussed the second derivative test, that is d of xy is equal to fxx into fyy minus fxy square. Then there is a first case, if d is greater than 0 and fxx is greater than 0, then the point must be what? Which point it is? It must be a local minimum. And if d is greater than 0 and fxx is less than 0, then the point must be maximum. And then we discussed third case, that is if d is less than 0, then the point is saddle point, and if d is equal to 0, then this test is failed or it does not give any information. In the today's lecture we have to solve some problems on local maximum and local minimum. So we start our topic in today's topic, that is the local examples on local maximum and local minimum. Examples on local maximum and local minimum. In this we have to take first example. We solve a first problem, that is find the local maximum and local minimum values and the saddle points of the function f of xy is equal to x raised to 4 plus y raised to 4 minus 4xy plus 1. So what is given? We have to write given f of xy is equal to x raised to 4 y raised to 4 minus 4xy plus 1. Okay, and now what we have to find? We have to find the local maximum and minimum. That is, we have to find the points first and then we have to find the value, that is the f of this point, and then we have to find the some saddle points. That means this is the third case of the second derivative test. So for this what we need to find? By the first derivative test we have to take fx is equal to 0, fy is equal to 0, then we have to find the critical points, and then we are going for the second derivative test. Okay, so for this what we have to find? Suppose fx at xy, it is equal to, so what is the derivative of this, partial derivative of this? That is 4x cube minus, it is plus 0 here, minus 4y plus 0 again. Now what we have to find? Fy is equal to, or fy of xy. So what should be this? 4y cube minus 4x. And now what is here important? Take fx is equal to 0 and fy is equal to 0. And then what we are getting? Therefore 4y is equal to 0 and 4y cube minus 4x is equal to 0. Then try to solve these both the equations. So what should be this? Y is equal to, what we can write? Y is equal to x cube. And here what we are getting? This is nothing but, suppose y cube minus x is equal to 0. Just dividing by 4. Then just put here value of y cube. Then what we are getting? This implies that y value is x cube. That means y raised to x cube raised to 3 minus x is equal to 0. And what is this? This is nothing but x raised to 9 minus x is equal to 0. So what should be common? X raised to 8 minus 1 is equal to 0. Try to factorize this. So what should be this? This is nothing but what? X into x raised to 4 minus 1 plus x raised to 4 plus 1, it is equal to 0. Is it? Then what we have to next find? Again you can factorize this. So what should be this? x, what we are written here, x raised to 4. So it should be what? It should be x square minus 1, x square plus 1 and x raised to 4 plus 1 is equal to 0. And therefore again you can factorize here x minus 1, x plus 1, x square plus 1, x raised to 4 plus 1, it is equal to 0. Now what we can write, this implies that x is equal to 0 or x minus 1 is equal to 0 or x plus 1 is equal to 0 or x square plus 1 is equal to 0 or x raised to 4 plus 1 is equal to 0. But if you see here, these are giving a which roots? These are giving a complex roots. It is not a real root. Therefore, we have a x is equal to 0 or x is equal to what? Or x is equal to 1 or x is equal to minus 1. Therefore, the values of x is equal to 0, 1 and minus 1, or we can say they are the root. We need only the real roots, so we are not going for the complex root because we are discussing the real valued function here. And therefore what we have to take next, now find y. Then what we are getting, if x is equal to 0, then you can put any of this, you can take any of this equation, then you can find the value of y. So what should be this? Therefore then find y, and we have, you can write any equation here, y is equal to x cube. So put this, y is equal to 0 cube, it should be, so y it is equal to 0, y should be 0. Next we can find x is equal to what? It is next is what? 1. Then y is equal to, here what is our first point here? 0 and 0. It is your first point. Okay. Then what can you find? X is equal to 1, then y is equal to 1 cube is equal to 1, therefore y is equal to 1. Therefore you are getting a second point, that is 1 and 1. Second point here. Now again you can find this, if x is equal to minus 1, then what you are getting, y is equal to minus 1 raised to 3, it should be minus 1, therefore y is equal to minus 1, and you are getting your third point, that is minus 1, that is the third point. Okay, which point these are? These are the points, critical points. These are the critical points. Where we are written this, take fx is equal to 0 and fy is equal to 0 for finding critical point. That is, for finding critical point we must take a first derivatives are equal and then factorize the given equation or solve the given equation, you will get the critical points. And now thus the critical point, critical points are, which are the critical points? 0, 0, 1, 1 and minus 1, minus 1. So these are the three critical points. Up to this what we did here, that is just we are written given for critical point we must take a first partial derivatives are equal. So we are taking first partial derivatives are equal, then we are getting a two equations, solve these two equations, find the values of x and y, then you are getting a critical points. And now at this critical point you have to use the second derivative test. So we use now second derivative test at 1 point, and then we have to check this at this point the value is maximum or minimum, or it is a saddle point. It is a saddle point. So what is our next target? Next target is we have to take each and every point you have to use the second derivative test. And for second derivative test, what is important? What is important? You have to find the second order partial derivatives. Second order partial derivatives. So here is what? Here is what? Now here is our first given function is there. What is your fx? Fx is 4x raised to 3 minus 4y, and fy it is equal to 4y raised to 3 minus 4x, and you must find fxx. Fxx is equal to 4 3s are 12 x square minus it is what? 0 minus 0, and what is your fyy? Fyy is what? 4 3s are 12y square minus 0. Find fxy. Fxy, that is derivative of fx with respect to y. This derivative is 0, and now it should be minus 4. Now you have to check at a 1 point. So we take at point, first point is 0 0. So our first point is 0 0. So what we have to write next? Now you have to find fxx at 0 0. It is what? 0. Fyy at 0 0, it is 0, and fxy is equal to minus 4 at point 0 0. You can write here. And now what is our d? D at point 0 0. What is our formula? That is fxx at 0 0, fy at 0 0 minus fxy at 0 0 bracket square from the second derivative test. So we can write from second derivative test. Okay, we write it is later on. So what find the answer here? What should be this? What should be this? fxx is 0 into 0 minus, here is what? Minus 4 square, it should minus 16. And therefore what we can write? D of 0 0 is equal to minus 16, and it is less than 0. So why the second derivative test? By the second derivative test, what we can find the conclusion? It is what? First case, second case, third case. It is a third case. Therefore what we can write? The point 0 0 is a saddle point. It is a saddle point. Why it is? Because d less than 0. If d greater than 0, you can take here two cases, that is fxx greater than 0 or fyy greater than or less than 0. Fxx less than or greater 0. So it is what? For what we are getting, the point f0 0 is a saddle point. Now we have to go for the one more, that is the next point. Next point is what? Second point is our at point 1 1. Now what is your fxx at 1 1? Fxx at 1 1, 12 into 1 square, it should be 12. So fyy at 1 1. Fyy at 1 1. So what we are getting here? Again 12y square, so it should be again 12. And then what is your fxy? It is minus 4. So again you have to write d of 1 1, it is equal to. So what we can write? fxx at 1 1, then fxx at 1 1 into fyy at 1 1 in minus what? fxy at 1 1 bracket square. Okay. Now what we can do now, just put the values. So d of 1 1 is equal to fxx at 1 1 is 12 into fyy at 1 1 is 12 minus 4 square. So what is it? It should be what? It should be 12 12s are 144 minus 16, and it is equal to what we can write? 128. It should be 128. So what is our d of 1 1? D of 1 1 is greater than 0. It is greater than 0. Therefore d of 1 1 is greater than 0. And what is our fxx at 1 1? Fxx at 1 1 is what? It is 12 and it is positive, so it is greater than 0. Therefore use from second derivative test, we get what we are getting. D greater than or 0 and fxx is greater than 0, thus we get which point 1 1 is a local, or which it is what? Local maxima or minima. It is greater than, therefore it should be local minimum. It should be local minimum. Now can you find the local minimum value? Thus the local minimum value, and how we find this? You have to find f minimum at 1 1. It is equal to, at point 1 1, just write down this: 1 raised to 4 plus 1 raised to 4 minus 4 into 1 plus 1, and equal to 1 plus 1 minus 4 plus 1, and it is equal to minus 1. So our f minimum at point 1 1 is minus 1. Thus the local minimum value at 1 1 is what? Minus 1. It is minus 1. Similarly you can find third one, that is you have to find now at point minus 1 minus 1. Now what we can find at point minus 1 minus 1? If you have to find fxx at what? 1 1, it should be what? 12. 12x square means 12 minus 1 square, it should be what? 12. So again fyy at what we can write here? At point minus 1 minus 1, it should be again 12. It should be again 12. So, and our fxy is our minus 4. So all the values are same, therefore all the equation, all the values, all the statements, or you can say all the calculations is same. Therefore what we can write here? D of minus 1, it is equal to again a same value 128, which is greater than 0, and our f of minus 1, which one xx, it is again a 12, and it is again a greater than 0, and therefore what we can write? Thus by the second derivative test, what we can write? The point which point minus 1 is local minimum. It is a local minimum, and therefore what we can write? F of minus 1 minus 1, it is equal to, you can find again, put the value minus 1 raised to 4 minus 1 raised to 4 minus 4 into minus 1 plus 1, and it is again a 1 plus 1 minus 4 plus 1, it should be minus 1. Thus f has a local minimum at 1 1 minus 1 minus 1, and local minimum value at -1 is -1. So this is the problem, you have to solve that much. It is very important problem, that is find the local maximum and local minimum values or saddle points. So how we summarize this? How we summarize this? How we can write summary? Those are what are the steps to find the local maximum and minimum. So what we did first we use first derivative test. First you have to take a first derivative test, that is what, fx is equal to 0 and fy is equal to 0. First what we did, we use a first derivative test, and then what we have to write, then we have to solve fx is equal to 0 and fy is equal to 0, find critical point. That is, you have to solve these two equations, and then you are getting a critical points. And then third point, use second derivative test at each point. That is, you have to use the second derivative test for each point, and then you have to find the local maximum value or minimum value by putting this point value, it is in the given equation. So there are 4 steps. First use this that is, use first derivative test, that is fx is equal to 0, fy is equal to 0. Solve these two equations, you will get the critical points. Then check at every point, use a second derivative test and check it is whether local maximum, local minimum, or it is a saddle point, and then put this point value, it is in a given function. You will get the what you can say, you will get the corresponding local minimum maximum value. Okay, so we will solve one more problem here. So we will go for the second problem. So what is our second problem? Find the local maximum and local minimum values and saddle points of the function f of xy is equal to x square plus y square plus xy plus y. So what we can write now? Solution. So what is given? You have f of xy is equal to x square plus y square plus xy plus y. Now what we can solve here, what we have to use? First you have to use the first derivative test, that is fx, you have to take fx is equal to 0, fy is equal to 0, and we have to find the critical points. For this we have to find the what is must, that is we have to find the first derivative test. So what is fx at xy? So it should be 2x plus 0 plus y, you can write. What is fy at xy? Fy at xy, it should be what? It should be 2y plus x plus 1, here plus 1. So fy xy, what should be this? fxy, that is derivative of this with respect to y, it should be what? Our 1. No need to find fyx. So what you can find? fxx. So what is the derivative of this again with respect to x? It is 2. What is the derivative of this with respect to y? It is again 2. Here is 0 and here is what? 0 again. So now what we have to take for critical point? For critical point, what you have to take fx is equal to 0 and fy is equal to 0. So what is our fx? Fx is 2x plus y is equal to 0 and 2y plus x plus 1, it is equal to 0. So what we can write here? Y is equal to what is our value? y is equal to minus 2x, and this implies that put this value y here, 2 into minus 2x plus x plus 1, it is equal to 0. That is, we are try to solve this both the problems, and what we are getting now here, 2 to the minus 4x plus x plus 1, it is equal to 0. And what we are getting from this here is how much? Here is 3 minus 3x plus 1 is equal to 0, and you can write here 3x is equal to 1, and therefore x is equal to 1 by 3. This is our x. So y, x is equal to 1 by 3. Put here x is equal to 1 by 3 in y is equal to minus 2x. And what should be your y? Your y is equal to minus 2 upon 3. So your y, you are getting y minus 2 by 3. Okay. And thus what we can write? Thus the critical point is, what is critical point? Our 1 by 3 and minus 2 by 3. 1 by 3 and minus 2 by 3. So now what we have to use? We have to use the second derivative test, and for this what we have to find here, f(x) at point 1 by 3 minus 2 by 3. What should be this? It should be no need, here is no x and y, so not a change in value. Here fyy at 1 by 3 minus 2 by 3. Here again similar fyy, it is again 2, no y and x, so no need to put here value. And again fxy, what is our fxy? It is again at point minus this. There is no point x and y here also, so its value is again same. So now we have to find d of what? 1 by 3 minus 2 by 3. What is your this? fxx at 1 by 3 minus 2 by 3. Use the formula fyy at 1 by 3 minus 2 by 3 minus what? fxy at minus 1 by 3 or 1 by 3 and minus 2 by 3 bracket square, and just put the value. What should be this? 2 into 2 minus 1, and it is what? 4 minus 1, it should be 3. So our d of 1 by 3 minus 2 by 3 is equal to 3. It is greater than 0. And what? Our fxx at 1 by 3 minus 2 by 3, it is greater than again 0. It is greater than again 0. Therefore what we can use? Therefore by second derivative test, what we can write? The point 1 by 3 minus 2 by 3 is a local maximum or minimum. D greater than, here fxx is greater than, therefore it should be local minimum. And therefore we have to find this value, that is f of at 1 by 3 minus 2 by 3. So put there here value, it should be minus 1 by 3 square plus minus 2 by 3 square plus 1 by 3. Here is not a minus, 1 by 3 into what? Minus 2 by 3 plus 1, or y is what? Minus 2 by 3 again. So what should be the value here? 1 by 9 plus 4 by 9 plus, here is what? Minus 2 by 9 minus what? 2 by 3. Minus 2 by 3. Just do the calculation. 1 plus 4, 5 minus 2. 5 minus 2 is 3 by 9 minus 2 by 3. It should be what? 1 by 3 minus 2 by 3, and it should be minus 1 by 3. So our f 1 by 3 minus 2 by 3 it is equal to minus 1 by 3 is local maximum or minimum value. This is the log value. Okay, so in the similar way you can solve so many problems like this. It is very important problem, but if you see first problem and second problem, here is a sum, that is here we are getting only one critical point, therefore answer is short. That means you are check this at only one point. So it depends how this question asks for 1 mark or it is for 4 mark or it is for 3 mark. That is, if the mark is more, then problem length may be longer. Okay, so find critical point, this type of question can be asked for 1 mark, and find local maximum, local minimum, this type of question can be asked for 5 marks. So it is very important problem. What are the steps? First you have to take fx and fy is equal to 0 for finding critical points, and then second point, that is you have to check at each and every point you have to use the second derivative test, and then you have to find the local maximum or minimum value. Okay, so just keep in mind how we have to solve. It is very important, again I am saying. So in the next lecture we take up some theory problems on the local maximum and minimum. Today we will stop here. Thank you very much.